Yeah, good morning all. Sorry for the delay. So in the last class, we looked at type conversion, right? We looked at three kinds of type conversion: implicit type conversion, explicit type conversion, and conversion of non-compatible types. Implicit means if you just assign one type of variable to another type of variable, it automatically does that if it is possible. You need not specify what type you need to convert it to. Explicit means sometimes it is possible that some data might be lost if you try to assign one type of variable to another type of variable. In that cases, it it doesn't take the risk. It doesn't want to allow that. So it wants you to explicitly state to convert from one type to another, assuming you know that there is no data loss or you are okay with data loss. Okay, so that is explicit type conversion. So that is also called type casting. And conversion of non-compatible types, that is like say, even if you specify explicitly the type, it does not work because the process of explicit type conversion is similar to implicit type conversion, but there are some non-compatible types which follow a different process. In that case, you need to sort of use some methods like convert, some functions like convert or parse to convert one type to another type. Okay, so these are the three types that we saw. All right. So these were the examples. Like initially, say we wanted to convert int to byte. That is not possible by default. It cannot be implicit type conversion. So you have to explicitly state that you want to convert it to byte. Okay, then it will do it. Similarly, say float to int. That is also not possible by default. Implicitly, you need to explicitly state that you want to convert float to int. Okay, but if you want to convert a string to int, even if you give a converted word like string or int, it will not convert it. Okay, so because it follows a different process. So here you have to use functions like convert. So convert dot, it can be you can convert a string to int or convert a string to float depending on the kind of string you have. That should have only digits or related data type content. It can be bool also, like true false. String can be true false, then you can convert it to bool. String is a sequence of digits, then you can convert it to int. It can be a sequence of digits with a decimal point in between, then you can convert it to float or double or whatever. So depending on the type, depending on the content of the string, you can convert it to a specific type. All right. So you can use convert dot to int32 or to int64 or to byte or to float or to boolean. So different things depending on what type you want to convert it to. All right. And another method is, each of these data types come with a method called parse. Okay, so int dot parse or float dot parse or bool dot parse or double dot parse. So any data type you take, you can have a parse method, and that is another way to convert a string to that data type. Okay, so these are the different type conversion methods that we looked at in the last class. Today, let's move on to the next topic, that is types of operators. So far we just assigned values to variables, but we perform different kinds of operations, right? So what are different kinds of operations you know of in programming? Yeah? Or, and, yes, what else? Sorry? Greater or less than or equal to? Bitwise, right? Yeah, so we have this set of operators usually in any programming language. Similarly in C# also we have 5 types of operators. Basic arithmetic operators, which we have in any programming language: addition, subtraction, multiplication, etc. and then greater than, less than, like you said, those are called comparison operators. And assignment operators, and logical operators, and or, those are logical operators, and then bitwise operators. Okay, so let's look at each of them. Sorry, arithmetic. You know all the basic arithmetic operations, right? Like addition, subtraction, multiplication, division, and remainder. So whatever are there in C, same arithmetic operators are there here. Now, only thing which you, I don't know if you remember, suppose if I ask you, okay, so let me delete all this and let me change my directory to operators. Yeah, suppose if I say int x equal to 5, int y equal to 2, and int z equal to x by y. Okay, now if I try to print z, what will be its value? 2. Why? Integer division. If both the operands are integers, then the result will also be an integer, right? Yeah, so let's run it. Yeah, it's 2, it's not 2.5. If you want to make it 2.5, what we should do? Float. What float? This will work? Sorry? Float should be in front of the operation. Like how? Loudly, little loudly, or you sit in front. Int z equal to float x by y. Okay. So we convert x to float. That's what you're saying. Let's see. It's not allowing. It's saying cannot implicitly convert type float to int. An explicit conversion exists. Are you missing a cast? So what should we do? we should declare z as float, and we leave x and y like that. No need to convert x or y to float. Let's try that also. So okay, let's try all the different methods. First, everything is int, okay, then we declared z as float. It can't be z, it has to be some other variable, let's say p, and x and y are still integers, okay. Now let's run it. Okay, I have to print this also. Okay, you're still getting 2 only. So what to do? Sorry? F after x by y. No, that won't work. It will try to take it as a variable yf. F is only after a constant number, not a variable. Type conversion of what? X and y. Okay, let me write another line. So left hand side will be float only. Okay, so let's say float q equal to, so you're saying convert x and y to float. Okay, and let's print q. All right, yeah. Yeah, it's working now, right? Now let's make only one of them float. Let's see what will happen. It will work. Okay, why do you think it will work?
Because both the to which it is getting assigned is a float and to which it is dividing is a float. So if the denominator is int, it doesn't matter.
If the denominator is int, it doesn't matter. Suppose if I make the numerator int and the denominator float, then it won't work. First, let's see this. Even now it is working. Now let us change, or let me copy it. Earlier we made both float. Okay, let's leave it there. Let's say R, where only one of them is float, and then let's say S, where only the denominator is float. So how many of you think this will work? This will give a float? Or how many of you think this won't work? Won't work. Why?
Dividing an int.
Okay.
I'm not sure if it.
You raised hand. Why do you think it won't work? Okay. Okay. Let's see. I need to print, sorry. Okay. Worked? Simple thing, if any of the operands is a float, the entire result will be a float. Even if one operand is float, It doesn't matter what the other operands are. It is like there is a, you can think of it like a superset, right? Int is greater than byte. Like implicit conversion, the way implicit conversion works, it is, you can convert a byte to int without any effort, because int is sort of a superset of byte. Byte is an integer, but all integers are not byte data type because byte is smaller. Okay, so if you add a byte and int, the result will be an integer. It will automatically increase the size of byte by adding more zeros. It will make it an integer, and it will add that to the other integer, and the result will be an integer. Similarly, if you add an int and float, the result will be a float, because float is a larger data type. All integers are sort of floats. All natural numbers are real numbers, but all real numbers are not natural numbers, right? So if you add a real number and a natural number, the result will be a real number. So whenever there is a possibility, it will automatically do that, right? But when both are integers, okay, if both the operands are integers, then the result will be an integer. Although technically normal mathematics 5 by 2 is 2.5, but in a computer 5 and 2, if they are declared as integers, then 5 by 2 will be only 2. It will take only the quotient part. It will not take the remainder. Okay. So we need to convert at least one of them or both of them. It doesn't matter which one you convert. It can be numerator, it can be denominator, or it can be first operand, second operand, third operand. It doesn't matter. At least one operand in that operation should be converted to float. Then the entire operation will be treated as operation of floats or operation of real numbers. Got it? This is same in any programming language. Even in C, it is the same. Integer division will give you only integer output, and that will be the quotient of the integer division. If you want real number output, at least one of them should be float. It's not necessary that even both of them should be float. Even if one of them is float, it will do real number division. Okay, so this is something you need to keep in mind. This is usually a place where students make mistakes. They declare both x and y as integers, and then they do division somewhere, and then they are not getting real number output, so they confuse why is it not happening. Okay, so don't make that mistake. Yeah, so the rest of the operations you know, quite simple, addition, subtraction and all that. Modulus also you know, right? Modulus will give you the remainder. Division will give you the quotient of integers. Modulus will give you the remainder of integers. That's all. Okay. Then there are two more arithmetic operators which you would have heard of. Plus plus and minus minus. What are these? Increment and decrement operators, right? Now within this there are two types. Within each, do you remember?
Equals to plus and is equals to like assigning incremental value and assigning decremental.
No, these within each, within increment there are two types, within decrement there are two types. Exactly, post and pre. So within this we have like post increment, like x plus plus, and pre increment plus plus x. Similarly within this we have post decrement, x minus minus, and pre decrement, minus minus x. So what is the difference between post and pre? Right. Yeah. So suppose suppose I say int a equal to 5, and then I say int b equal to a plus plus. Okay. Actually, let me write it later. Why it is not pasting? Anyway, So these are increment and decrement operators. So int a equal to 5, int b equal to a plus plus. Now if I print b, what should I get? What will I get? 6. How many of you think 6? See, these are basic things. You are in 4th year. These are like basics of programming, and you're not sure of even such small things. I don't know what to say. It's like you need to learn programming from scratch. So let me comment this for now. It is 5 only. Suppose instead of this, if I say int c equal to plus plus a, and I write print c, what will c be? Yeah, c will be 6. So it first increments a and then assigns a to it. In the previous case, it first assigns a and then increments a. So that is the difference between post increment and pre increment. It can not only assignment, any operation. If I do, so first let me print this and then I'll explain. Yeah, actually a was already incremented in between. A became 6. So let me first print a. So let's say a equal to plus a, b equal to plus b, and then again let me print the value of a, and then let me print c equal to plus c. Okay. Why is a6 here? Yeah, okay, I need to print a here actually, sorry. Yeah. Okay, first a will be 5 and 5 is assigned to b, so b will be 5, but then a is incremented, so a becomes 6, and then when you assign plus plus a to c, first 6 is incremented to 7 and then that is assigned to c. Okay, so here also you can print the value of a. Okay, first a is 5 and then you said b equal to a plus plus. So first b is assigned to a, b becomes 5 and then a increments to 6. So immediately when you print a, it will become 6. Now c equal to plus plus a, so 6 becomes 7 and then it is assigned to c. Okay, so that is the difference. Now say you use it in a slightly complex expression, d equal to b plus a plus plus. Now what will be the value of d? Yeah, same as b.
5 plus 7.
Hmm.
5 plus 7 and then d it get assigned to d.
Hmm.
After that it increments to 1 and we don't.
What increments to 1?
That 5 plus 7.
5 plus 7 increments to 1.
No, it's 12, sir. In the next step, the plus plus gets incremented, then we'll get it as 13.
Okay. Any other answers? See, are we doing a plus plus or are we doing entire thing plus plus? Then why are you saying entire thing will increment by 1? What? I just said you're wrong. Okay, I didn't understand your nod. I thought you thought that I agreed. So what will increment? First half is correct. It will be 5 plus 7. Okay? Then what will happen?
Then a value gets incremented by 1
Hmm.
and that's it. A becomes 8.
That's all. Okay? Only a will be incremented. But before incrementing, the previous value is used in the larger expression. Okay? Now we can also print a. Okay? You see, D is 12 and A became 8. Okay? So only A is incremented, right? Now, instead of A plus plus, if I write plus plus A, then what will happen?
The incremented value of a gets added to b, so it becomes 13.
Mm.
And a is 7.
A is? A is 8. First A becomes 8 and then that 8 is added to B, 5, 13. And 8 remains as it is because it is already incremented. Okay? So let's test this. You see, D is 13 because A already became 8 and then added to 5. So that is the difference between pre-increment and post-increment. In post-increment, the existing value is used first, and then the existing value is used in the larger expression, and then that particular variable's existing value is incremented. So that is not reflected in the larger expression. Whereas in pre-increment, first the existing value is incremented and then that is used in the larger expression. Similarly, post-decrement and pre-decrement. Okay, that's the difference. All right. So let me create one more. Yeah, just for your reference. Now it doesn't matter whether you write a plus plus at the end or in the beginning. I mean, this same thing this will also give you the same result. The point is whether it is post increment or pre increment. That's all. It does not matter whether you write a plus plus as the second operand or first operand. Okay. Yeah. All right. So that is arithmetic operators. Clear? No doubts, right? Yeah. Now let's look at assignment operators. Assignment operators are quite simple. Basically, you know the simplest assignment operator, that is equal to, right? And then you have plus equal to, minus equal to, multiplication equal to, and division equal to. So what do they mean? Plus equal to means?
Increment and assign.
Yeah. So suppose if I say A equal to B, it is simply A equal to B. But if I say A plus equal to B, what does it mean? Yeah, that's all. A equal to A plus B. Similarly, A minus equal to B means A equal to A minus B, and this is A equal to A times B and A equal to A divided by B. That's all. Okay, so straightforward. Just this is just like a shortcut for a larger expression. All right, so I won't spend much time on this. And then comparison operators. So here you have equals, not equals, greater than or equal to, less than or equal to. Okay, so if you have to compare whether two things are equal, then you have to use double equal to sign, not single equal to. If it is single equal to, it will assign it, it will not compare it. All right, and not equal to, exclamation mark and equal to sign, and greater than or equal to, less than or equal to, right? These are the different comparison operators. Okay, and then logical operators. So what are the different logical operators that you know? Yeah, and then or, and that's it. Yeah, not. Okay, so this is and, or, not. Okay, these are three things, and they will apply on what kind of data types?
Equal when both sides are of equal depth, like similar, same data types.
So on all kinds of data types, the only condition should be they should be of same type. That's what you're saying. So give me an example of AND operator. What is its input and output normally?
In if statements, we use AND operator to see if the condition is satisfied.
Yeah,
If two conditions are satisfied or not, both the conditions are satisfied, we'll get the
so when do you say a condition is satisfied?
when the input we gave is in the range of what is it?
How do you specify the range? Normally in logic, logic, truth tables. Yeah, Boolean. So there we use these, right? And, or, not, right? So what are the inputs and what is the output? Types. Truth tables. Forget programming.
It's Boolean.
Yeah.
It's Boolean.
Yeah. It's just input is true or false and output is true or false. Input is a pair of true false values and output is either true or false. So what are these equivalent types in programming? Input, I just said, I put it on a plate and gave you. See, simple, no? I mean, if something is true and something else is true, then the output is true. So what are the inputs? True false values. So true false values belong to which data type? Boolean. That's all. Why are you so confused? I don't understand. So input should be of Boolean data types and output will be a Boolean data type. Input is a pair of Boolean variables, output will be a Boolean type. That's it. In arithmetic operators, what are the inputs and outputs? Sorry? Yeah, all numbers like integers, floats, double, all this. Okay? In assignment operators also it's the same, right? Arithmetic operators only you're sort of combining, assigning and combining, adding, subtracting, all those things. That is assignment operators. So again it will be integers, floats and all those things. First assignment operator, only the single equal to thing, that can be for anything. That can be for a string, you can assign a value to a string, or that can be for a bool, you can assign a value to a bool and so on, but you can't add them. I mean, adding a string will give you a different meaning. Like you saw here in the console.writeLine statement, what am I doing? Adding a string to an integer. Right, I'm concatenating the string. Although d is an integer, when I use it, when I add it to a string, it is treating this plus not as addition but concatenation. You see, again, that is like, this is an example of operator overloading. Same operator gets different meanings in different scenarios. If the plus operator is found between two numbers or floats or whatever it is, it means addition. But even if one of the operands is a string, it means concatenation. So the meaning has changed. In one case, plus means addition. In another case, plus means concatenation. Alright. So depending on the operator, the compiler automatically decides what to do. This is same in Python also. This is how you add strings, right? Or concatenate strings. So plus between two strings means concatenation, plus between two numbers means addition. Right? Like earlier, like we discussed, if you add an int and a float, the result will be an integer. Here if you try to add an int and a string, the result will be a string. But this is not exactly implicit type conversion. It is first converting the int to string and then concatenating that string with the previous string. That is what is happening. Okay? Anyway, so normally assignment can be used on any operator, but addition, if it is used on string, it's of completely different meaning. Normally, then it's not an arithmetic operator anymore. It's a different operator. Okay? But for it to be treated as arithmetic operator, you can use it only on arithmetic values, numerical values. Okay? Not on Boolean, not on strings, not on char also. Only integers, floats, doubles, etc. Okay? Alright. And then comparison operators. The first one can be used with any type. It's like you can compare to strings, you can compare to Boolean values, you can compare to integers, to floats and all those things. And second one also you can use for all. But greater than, less than, they can be used only for numbers. Okay? And logical operators, they can be used only for Boolean values. You can't use it for numbers. In C, you can use it for anything. In C, you can use it for numbers also. Because in C there is no separate bool type. The so-called Boolean types are handled with ones and zeros only. 1 and 0. 1 means true, 0 means false. So 1 and 0 here have a dual meaning. So here rather than operator overloading, it is sort of operand overloading. 1 and 0 themselves get a different meaning based on the operator. If 1 and 0 are used in arithmetic operation, they are treated as normal numbers. But if they are used in a logical operation like AND, OR, then they are treated as Boolean values. Okay? Not only 1 and 0, actually any number other than 0 is treated to be true. It can be even negative number, it can be 5, 10, minus 20, minus 30, all of them are considered to be true when they are used in Boolean operation or logical operation. Only 0 means false. Okay? So that is possible in C because there is no separate bool data type. Whereas here we have a separate bool data type. So logical operators take only this data type. They won't take number. Okay? The concept of AND OR means if something is true and something is true, then the result is true, right? So inputs are pair of true false values, output will be true false value. So you have to have Boolean inputs and Boolean output. Okay? So that's the difference. And finally, we have bitwise operators. So what bitwise operators you know? Bitwise or? XOR. Okay. You directly told the complex thing. There are simpler things. Yeah? Yeah. So there is in C# we don't have XOR, bitwise XOR. In C# we basically have bitwise AND and bitwise OR. You see the difference? In logical AND we have 2 ampersands. In bitwise AND we have only 1 ampersand. Similarly, in logical OR we have 2 bars. In bitwise OR we have only 1 bar. That's all. Now, what is bitwise AND and bitwise OR? Okay, so let me give you an example. In bitwise AND and bitwise OR, what are the inputs? Sorry? Binary numbers. Yeah, but do you first convert your number into a binary number and then give as input? How do you?
We'll give integer or it converts automatically. So begin numbers.
Yeah, you give a number, it will convert it to binary form, calculate in binary, and the final binary thing it will convert back to decimal. So the inputs are integers and the output is also an integer. Okay, so simple example, let's take say 5 and 2. So I can give this as input. I can say x equal to 5 bitwise and 2. So what will it do? First it will take the binary value of 5, that is 101, and it will take the binary value of 2, that is 10. Okay, and you can fill this with zeros. So now it will do AND of bit by bit. Here they will be like true false. 1 and 1, only that is the case where output is 1. In all other cases output is 0. Okay, 1 and 0 is 0, 0 and 1 is 0, 1 and 0, 0. So 5 and 2 is 0. Suppose I do 5 and 3. So that is 101 and 3 is 1 1. So I put a 0 here. 1 and 1 is 1. 0 and 1 is 0. 1 and 0 is 0. So this is 1. So 5 and 3 is 1. Okay. Let's take 5 or 2. Okay. Again same 1 0 1 0 1 0. So 1 or 0 is 1. 0 or 1 is 1. 1 or 0 is 1. So what is this equivalent decimal value? 7. Yeah, so 5 or 2 is 7. Okay. So these are useful particularly in system level programming, like in socket programming or system level programming. Say even when say you want to find whether a number is even or odd, simple thing is the last bit, if it is 0 it is even, else it is odd. Okay. So you can use, instead of checking, instead of trying to divide that number with 2 and then checking for the remainder, you can do a bitwise operation. I mean, I will leave it as homework to you. What bitwise operation do you need to use to check whether a number is even or odd? So you need to do a bitwise operation with some digit, 1 or 0. I am even giving you that clue. So some bitwise operation, say if I want to find a number n, whether it's even or odd, so you need to do n and some bitwise operation with 1 or 0. You need to find which digit and what is the bitwise operation.
Because if we take OR only, we'll get the true value of the number which we want to check.
Or with what?
Or with the number which we want to check.
Or will have two operands, right?
Or
Number or
number or one. Number or 0. Because 0 and 0 will give, only 0 and 0 will give 0 in OR, and rest all cases it gives 1. So it gives the first digit as the true digit of what it is.
yeah. You can also use AND operation. If it is AND, then the bit will be, you should do AND with 1, right? If the result is 1, it means the last bit is 1, else the last bit is 0. Okay? Yeah. Yeah. So now division operation is more costly. This is much simpler, and always whenever you have a bitwise operation, for any other operation the equivalent bitwise operation is always faster. So if you are in interview, if you give a solution and if someone asks you to optimize it, if there is a bitwise solution, that is the best solution. Division, addition, whatever it is, bitwise is much faster. Okay. All right. So let me quickly work out a couple of examples. Operators we saw. So let me rename this arithmetic operators, and okay. So let's say let's just say int x equal to 4, int y equal to 5. I will not do arithmetic operators, you know all that. Increment, decrement we saw, and assignment operators we can just say int z equal to sorry, we can just say x plus equal to y, and now print x. So what will be the value of x now? So before this line, what is the value of x? 4. After this line, what will be the value of x? 9, right? I need to change to, sorry. Yeah, 4 and 9. Okay, straightforward. So similarly, subtraction, multiplication, whatever it is. I can even write this entire expression in this. I can say x plus equal to y. Let's see. Yeah, that will also work. Fine. And then comparison, you know, suppose I say x not equal to y. It should output a Boolean value, right? It is true. So yeah, okay. One thing you need to notice is, you see, when it prints true or false with a capital letter, first letter. But when you assign to a variable, they should be of small letters. True or false in the code should be of small letters, all small letters. Okay. So now let us say and x equal to y. What should this be? So first you need to calculate this value. Its value is true. Its value is false. So true and false is false. False. Okay. And then finally, so we covered all. Yeah, logical also we covered. Not, you know, so if I just take this, sorry, x equal to y, or let's say x greater than or equal to y. Okay, this will be true. Yes, yeah, sorry, yeah, x is 9, so this will be true. Yeah, now if I just put not, this will be false, right? Yeah, now so logical are over, assignment, yeah, comparison is over, only bitwise is remaining. So bitwise, let's test our examples 5 and 2 and 5 or 2, 5 and 2. Okay, so output should be 0. Let's also test 5 or 2. Okay, output should be 7. Okay, so you need not convert it to binary. It will convert to binary at the back end and do the calculations, and the result it will convert back to decimal. Okay, so these are the basic operators, and in next class we will start classes. We will discuss classes. Okay, yeah, let's stop here.